In today's video, we're going to be discussing further nomenclature rules. First, I'd like to talk about priority groups. Different substituents and functional families will have a different level of priority in a compound. So alcohols are the first priority group, and there are many other functional families over which alcohols will take precedence. Say we have this compound with an alcohol group and an alkene in it. Although I have not written out the full list yet, alkenes are lower in priority naming than alcohols. So this shape would actually have to have the alcohol on the lower number rather than the alkene, and this entire shape will be named as an alcohol. So if you did not know about the priority naming between alcohols, alkenes, and other groups, you might name this incorrectly. If you had numbered it the other way around, with the double bond getting the lower number on carbon 2,3, it would be named as a 4-hydroxy because on carbon 4 you have a hydroxy group. Recall that when alcohol is a substituent, it's hydroxy. And your main chain is 5, so pent. The double bond is on the 2, or starts on the 2, ene. It would be 4-hydroxy pent 2-ene. Well, this is wrong. You can't name the shape like this, because alcohols actually take higher priority over alkenes. We are going to number it the other way around, to put this alcohol on the lower number. So it would actually be named the other way around like this. And the alcohol group is going to be in the main chain. I haven't yet talked about naming alcohols, and I will in a further video. However, for the sake of this video, I will show you how the compound will be named. So you have a main chain of pent, which is 5 carbons. You have a double bond on the 3. Ene for alkene, but the final name is not going to be ene, because now the main functional family is an alcohol, since alcohols take priority. And the alcohol group is on a 2. When we name alcohols, we put OL at the end and a number before the OL to indicate where the alcohol group is actually placed. Before the ene, we place the number of the double bond to show where the double bond is placed, and then we have the name of the main chain. So it would be pent 3-ene 2-ol. Now say this shape was changed to a thiol group, which is otherwise known as a sulfur alcohol. Even if we have all of these other substituents, the chlorine, the alkyl group, the double bond, in our shape, the SH or thiol group is going to be named as the main chain. So it is going to be all of our substituents dash thiol. Now say we have a shape like this, where we have a double bond, a chlorine, and a triple bond in the same shape. In this case, alkenes are going to take priority, and you will be naming the main chain as all the substituents dash ene. Now say I have a shape like this, where it's just a toss between the triple bond and the chlorine. Triple bonds are 4th highest in priority, so if there are no alcohols, thiols, or double bonds in this shape, we are going to name this as an alkyne. So recall that it's all of our substituents dash -ine at the end. Now if we have a shape like this, alkenes are the lowest in priority. If we have any halogens or nitro groups on our shape, and there are a couple other substituents that might fall into this category, we are going to just name the shape as an alkane, because putting a nitro group or a halogen, such as chlorine here or maybe bromine, is not going to change the actual functional family. It's still an alkane. Now I want to talk about branched substituents, or substituents that come off of other substituents. For example, say we have a shape like this, a 9-carbon chain with this branched alkyl substituent coming off of carbon 4. Rather than manually having to name a substituent within a substituent, there are special names, such as tert-butyl, sec-butyl, isopropyl, and so on. I talk about these in my previous video. But what if you don't want to use those? There is a way to manually name them, because not every branched substituent has a special name for it. So if we took a look at something like this, it would be an ethyl group. But what if we have this coming out of it? We can go this way and it's an ethyl group of 2 carbons, or we can go this way and it's still an ethyl group. But it doesn't matter which way our ethyl group goes, because out of this carbon it branches off into another group. So the way we name these is first identify the longest chain. Our longest chain was this carbon 1 and carbon 2. Now out of the carbon 1, this group here is a substituent because it is not on our main chain. We can't just name this as an ethyl group. because of this extra carbon coming out of carbon 1. One carbon has a prefix of meth, and a 1-carbon substituent is a methyl. We have 4 because everything is coming off of 4 on the main chain, dash, and we put our substituent in brackets, and the name of the actual main chain in black is no name, which goes at the end. Known because it has 9 carbons, ane because it's an alkane. So we name the branch substituent first. Off of this carbon 1 on the ethyl group, we have a methyl in yellow. So it is a 1-methyl coming off of the ethyl. So it is a 1-methyl ethyl. 4-1-methyl ethyl, no name. And that is how you would name a branched substituent. In my previous video, when I talked about the special names for certain branch substituents, this can also be called an isopropyl. So this is a 4-isopropyl, no name, if you wanted to use that special naming. Now say we have 2 or more of the same substituents in a compound. So for example, say we have this compound. We have 2 chlorines coming off of carbon 4 and 2 methyls coming off of carbon 2 and another methyl coming off of carbon 3. Recall that methyl groups are just CH3 groups. So when I say we have 2 or more of the same substituents in a compound, something like this has 3 methyls and 2 chlorines in the same compound. So going back to our earlier priority naming, alkanes have to be named first before halogens, which is why I numbered starting from the left side to put all of these methyls on a lower number rather than the right side. So when we have 2 or more of the same substituent, we don't repeat the name. We just put a di or tri or tetra or whatever prefix you need in front of our name. So our main chain is a pentane, which I'm going to write out at the end. And let's note down all of our substituents. We have methyls on carbon 2, another methyl on carbon 2, and one on carbon 3. And then we have a chlorine, which is, recall from my previous videos that a chlorine is a chloro as a substituent on carbon 4 and another on carbon 4. See how I wrote out the number that the substituent was on twice, or as many times as the amount of substituents we had. And now we're going to put it in alphabetical order. Chlorine goes first, so we have 4,4 dichloro. If we just had one chlorine, it would be 4-chloro. But because we have 2, we have to put the number that both of them are on. Even if they're on the same number, we put it down twice. And we put a di to signify that there are 2. We have 2, 2, 3 trimethyl. So note I needed 3 numbers here because I have 3 methyl groups in the shape, and I needed to put a tri in front of it because there were 3. Then I put the name of my main chain, which is pentane. So this is how you would name shapes when you have 2 or more of the same substituents in a compound. You need to put a prefix of di for 2, tri for 3, and tetra for 4. The rest of the prefixes should follow the regular organic prefixes where we have pent for 5, hex for 6, hept for 7, and so on. Next, we should talk about the exceptions to alphabetical order. Substituents must be put in alphabetical order when we are naming compounds. However, there are some exceptions. The first exception is that multiplier prefixes that I just talked about, where we have some of the same substituents in a compound, so these letters are going to be ignored. Di, the D in di, T in tri, and T in tetra, and so on, are going to be ignored. So for example, if I have a name like this, I would not look at the T or the D when putting it in alphabetical order. I would look at the M and the P, which are the names of my main chains. Now when we have branched substituents, for example, we have tert-butyl, cyclopentyl, sec-butyl, neopentyl, or other branch substituents in our compound, we are not going to name these under the names of these prefixes with the tert, cyclo, sec, neo, and so on. We're going to name them under the main chain, B for butyl, P for pentyl, B for butyl, and P for pentyl. The only exceptions to this are isopropyl and isobutyl, where they actually will be categorized under I rather than P or B. However, when we have branch substituents like I talked about earlier, like something like this, where we have this isopropyl group. But if we didn't name it as isopropyl, it would have been named as a 2-1-methyl ethyl. If there were other substituents in the group and you were putting them in alphabetical order, this substituent would not go under E for ethyl. It would go under the very first letter in the bracket, which is M for methyl. So that's all I wanted to talk about today. Just in case these exceptions or other rules come up while you're trying to name compounds, I wanted to make a video to clear any of those questions up. I'm leaving a link in the description below to the related blog post for this video, where I have further lessons on organic chemistry and other courses at my website, stemtutor.org.